This industrial event underscores severe mechanical dynamics where immense rotational torque from unguarded shafts creates instantaneous draw-in hazards that completely overcome human physical resistance. In this scenario, the operator survived because the fabric's ultimate tensile strength acted as a mechanical weak point, tearing apart to break the entanglement loop. This incident was driven by basic ergonomic failures, including hazardous proximity to operational components and loose clothing that expanded the active hazard envelope. To mitigate systemic vulnerabilities, facilities must install interlocking physical barrier guards and integrate passive emergency stops, such as foot switches or pressure-sensitive trip bars. Furthermore, any close proximity servicing strictly requires full lockout-tagout protocols. Ultimately, relying on fortunate fabric failure is never a substitute for isolating hazardous mechanisms. This home safety analysis breaks down a severe kitchen fire escalation. The crisis began as a Class B hazard when an improper intervention capsized a hot cooking vessel, releasing flammable liquid onto the floor. This spill expanded the surface area exponentially, accelerating vaporization until the grease vapors reached their lower flammable limit or FAL and triggered a sudden flash fire. Human panic overrode calculated safety protocols, leading to a physical manipulation that destabilized the hazard instead of using active suppression tools like a fire blanket. Proximity deficiencies also exposed children to radiant heat and pooling liquids. Prevention requires strict thermal source immobilization, utilizing oxygen deprivation smothering techniques with metal lids, and establishing dedicated child exclusion zones. Composure and basic fire science are the boundaries of safety. This technical analysis examines a port terminal collision involving an unladen tractor-trailer hitting a yellow container truck. The impact concentrated massive linear momentum P-mensiu onto the cargo's bottom twistlock system. Because shipping containers have a high center of gravity cog, this lateral force generated extreme rotational torque along the longitudinal axis, snapping the structural tie-downs and overturning the load. A primary cause was the left pillar and side mirror creating a conical blind spot, completely obstructing the driver's peripheral vision at a 45 circ angle. Compounded by layout hazards and the absence of stop signs, a timely brake application became impossible. To prevent such accidents, fleets should implement ADAS proximity radar, regular twistlock inspections, and a strict stop-proceed policy at intersections.